And similar attack that undid web for Wi-Fi.
Yeah, it was the same problem.
Yeah.
Exactly the same problem. Okay, yeah, different types of anonymous networks. The darknets. There is some software called a darknet, but actually it's a kind of network. Basically, well, I don't need to put that there. I get an encryption key for each of my friends. It could be a public key or it could be a shared secret key. And my node connects to your nodes, and your nodes in turn connect to other of your friends. I don't know those friends, but you connect on, and it becomes a small world network, not strictly a random network, but a small node network, since it will have some clustering among friends. So that becomes a huge peer-to-peer network, just one layer, so you just have the mothernet and nothing else. So we can organize it like this. Well, until now I haven't been able to organize it, because it's just one huge small world network. But at least we can do broadcast searches on it. So I can ask you your node, that you can ask other nodes and get a file and transfer it, not directly, but through all your nodes, download it. So but that means I don't know who gave me the file. I know it's a friend of a friend of a friend, but I don't know who that is. And everything is, of course, encrypted, so the government can see what you do, can't see what you do. And in a way, that's very strong, because I can trust my friend that he won't actually, well, you can eavesdrop what I'm doing, but I trust you, so it doesn't matter that you see what I'm doing, because we're probably doing the same shit anyway. So that's darknet, and there are several softwares to do that. Some even set it up manually, using SSH and stuff, so they was scripted and really manual, because it's very simple to set up. So it's just a small world network, and that was the first, as far as I know, the first anonymous networks I heard about. Then came Tor, and Tor uses, it has a number of servers spread out all over the world. And to set up such a server, you have to eat dinner with Arma, the guy that created Tor. So you have to spend an hour with him and pay his beer. So that's his way to gain trust, because he says, well, the government agency can't spend that much time with him, and he might figure out if they're a government agent. But then, anyway, I hope that they don't have the time.
Didn't the US Navy originate the Tor?
They actually, they hired him to do it.
Okay.
He was a researcher, a doctor or something at the university, and they had a problem. The US Navy research lab, every time they started a new project, they started Googling stuff, of course, checking what's available, what knowledge is out there. And some newspaper in America had a mole inside their ISP and watched what they were Googling. So they and published it. So, the Navy lab are going to look at laser-controlled missiles now. So they switched ISP, but the newspapers just got new modes and paid people off in the ISPs. It did not matter which ISP they used. They always figured out what they were going to do. So they realized they have to do some kind of anonymous networking, something where you can connect through a proxy, encrypt it, and then jump out anonymously onto the internet when you do your Googling. So they hired, his name is Arma. He's a really nice guy. And he's the guy who invented me to Berlin to make my talk there. And told the people about it, you should put me on stage. So he's funny. So he built the Tor network for them. Of course, that might sound scary, the US Navy, that's the government, but he seems, all his code is open source and everything, it seems reasonable. The problem is of these servers. We don't know if Arma is corrupt or not. Some of these servers, he's claimed that all those have had dinner with him and paid his beer, but some of those might be the US Navy, because we can't know if he's honest or not. So provided that Arma is honest, this is fairly safe and secure, but just fair. So that's the Tor network, as far as I remember. You probably read more about it, because it was like 10 years ago I read up on it.
So if he dies, Tor dies?
Well, he has some people working close to him that can take over.
Yeah, I think it's the exit nodes that are the most important.
Yeah, okay.
Because anyone can set up an internal node, because it's just a forwarding node.
It's the exit node that has to have dinner with him, perhaps.
Maybe, yeah. Like,
Or perhaps he realized that. But yeah, some of these servers, well, I like to call them servers, or proxies, or onion routers, as they call them. They allow you to go out on the normal internet. You can connect out from them, go web surfing, downloading files, or go to chat rooms or whatever. Edit Wikipedia if you like to. So this means you can anonymously reach the normal internet, and it actually works fairly well. They have some intelligence in their network, so if you send a short package, like for instance type a command in a chat room, that packet gets priority. Bigger packets, that's usually file sharing or downloading big images from a web page, they get low priority and goes slower. So everything little goes faster. So if you're chatting or just looking at a text web page, it feels very fast. If you do file downloading, it goes a bit slower, but still reasonable speed. Then of course it often gets congestion because it's server-based. So, but it seems so far we haven't heard about people getting caught by the government using Tor. So the government, even if it is corrupt, they're listening, they pretend that they don't do that, so they keep quiet about it. Okay. Yeah. The other one is I2P. And it has no service really. It just all those computers that take part of I2P, if you want an encrypted connection, an anonymous connection, you just pick 3 of them and connect. Well, if I'm here, like that. And that is my, not exit node, but my front end node, I don't remember what to call them, but my representative, so to speak. And that means from that where I can connect to somewhere else on the node. And as I mentioned yesterday, for most of you, you can also publish information that way, not only consume. So if I'm a reader, I connect like that, and a publisher, he makes the same thing. He makes an encrypted tunnel like that, and this node will be his entry point. So this node will announce that I can provide service this and that. And that means I can connect out from my tunnel and into the publisher, but no one knows where the publisher lives. So on top of I2P we have websites. For instance, we have a BitTorrent website where you can see what torrent files there are and people can write comments and everything, just like the Pirate Bay. And then you can run also the BitTorrent swarm on top of this. And there is a client that has support for that, one BitTorrent client. It has changed name now, but you can perhaps look it up for me if you're online. It used to be named like this.
oh yeah.
I think it's Voos or something. Voos. Okay. So that's it.
Yeah. Okay.
So Voos has an I2P plugin that you can plug in, and then it runs on top of I2P instead. I2P also has exit nodes so you can reach the internet, but it's not its primary purpose, so there's always a lack of them. So usually that doesn't work as well, it's too slow. So for surfing the normal web, use Tor, but for file sharing or using network internal services, use I2P.
Tor also has the ability to ship publish inside.
Yeah, Tor has the same internal services. But Tor isn't meant to do file sharing. So you can publish web sites and chat systems inside, but since it's server-based, there's always not enough servers. So if you do heavy file sharing, you clog the network, and they don't like that you do this. People do it anyway, but they complain. They say, please don't do that. But on the I2P, you're supposed to do this. It's meant to do that. So if you run an I2P node, you also use it. You have to expect that 70% of your bandwidth will be going to help other people. So it will load your bandwidth heavily, but well, you have to help out to be a part of it. And I haven't tried it myself because I've been lazy, but people I've talked to say that BitTorrent swarms here are really fast. So it really works well.
Just in ITP, that is part of the protocol that there is a forced sharing. Forced sharing, that's 70%.
Yeah, something like that.
So yeah, you get over the free riders then, but you have to.
Well, it's open source. You can go into the source and modify it, of course. But
Yeah,
then
yeah.
Yeah, so of course you can easily fix that. There is no incentive stuff or no trust system in it as far as I know.
Okay.
So they won't discover easily that you're cheating. But apparently there hasn't been a big problem since everything works fast and nicely. So most usually at least. So far there haven't been many free riders around.
Okay.
But if it grows and gets more popular, we probably will see more free riders than all those non-geeks, non-ideals will get into the network, and then it probably will happen, as usual. Yes. That is kind of three slightly different types of anonymous networking. I think none of them are ideal. I would like to combine them. I would like my first step in the tunnel would be to a friend, someone who I exchange keys with, because that I can really trust, and that really is not the government. And then the next step I would like to do to someone that I just met for a while on a congress, just exchange business card with. So I can't really trust him 100%, but still it's probably not government. And the third step I would do like I2P, I would do to any random node in the whole network, just to get far away from my friends. And usually we don't do more than 3 jumps, because 3 jumps is enough usually. And doing more jumps lowers the network too much and gets slow. So 2 to 4 jumps and then we stop. But ideally we of course would like to have 2 jumps on each level there, but that would be too slow. Perhaps now, when people have more bandwidth, it works. But yeah. Okay. Yeah. So, by the way, all these stuff, they need working peer-to-peer underneath them to all the stuff. They find nodes, get swarms working together. So they need all the other algorithms we have been talking about here to work properly. Okay. Let's see what I have more on my list. Is it perhaps time for a break?
Yep.
Yeah. Let's do so.